Hola, mi clase. We are doing 7.7, which is factoring special cases. So remember, we multiplied or distributed special cases, so now we're going to factor them. So it's perfect square trinomials is the result when a binomial is squared. So perfect squares, because it's the same thing, like 2 times 2 squared, right, is 4. So that's a perfect square. So if you look right here, we already pre-typed them for you. So it's like this, where we had a plus b is the same as a plus b squared. And so that's where we get this. This is the perfect square trinomial. Same here, it's just minus, okay? So if we look, and this is squared, and this is a perfect square, and this is a perfect square, right? Because we have a 1 right here. If I can take the perfect square of this, which, by the way, would get me b is 7, and times it by this, so if you look in the middle, and then times it by 2, and I get this, that's what's going to be a perfect square. So I square, in a sense, what I'm doing is I'm square rooting this to get 7, and then I'm going to take, this is my a, so a equals 1. I'm going to take a times b and times it by 2 to see if I get this middle term here, which we also called b. So if I take 1 times 7 and times it by 2 and in fact get 14, then I know then it's this kind of perfect square because it's also plus here. So when I factor this, I get x plus 7 squared. And that's all I have to write. I don't have to write it all the way out because it's exactly the same thing. So again, if we look here, if I square root this, a becomes 3. And if I square root this, b becomes 5. If I take 3 times 5 times 2, I get 30. But because it's minus, I'm going to use this one. See how in the middle is negative? It's minus. So then I get not a minus b, I get 3x minus 5 squared. Right, because technically I square root this too, right? So 3x minus 5 squared, and the reason I can just square it is because everything's a perfect square, and you can see the middle worked as well. So it says, how can you factor the difference of squares using a pattern? What is the factored form of x squared minus 9? So if we used our old form, right, we do x squared, I would do plus 0x, because, right, the middle's gone, minus 9. What I'm trying to find are two factors that multiply to this and add to this, right? So if I do negative 3 times 3, I get negative 9. And if I do negative 3 plus 3, I get 0. So it means my factors are negative 3 and 3. And so I do x minus 3 and x plus 3. So this isn't a perfect square, but it is the fact that I can actually just square root this and make the two terms, and square root this and make that my coefficient. So if you notice, it is actually still the square root of this, just one of each, and it is the square root of this term, right? See how the 1's missing? So it still works. That's why it's called a special, because the 0 in the middle disappears. It's like when we factored special, I mean not factored, distributed special ones, we had this version. So it's just the backwards version of this. So that would be this form. So I wrote that form down here for you, right? A minus b, a plus b is when we get a squared minus b squared. So if we look here, I square root here. Oh, no, I totally lied. Watch, we're going to pull some stuff out. Look, I'm going to divide by 3. So that's going to be part of my greatest common factor, right? 3. And I'm going to divide out an x, because I have an x in both. So that's going to be part of my greatest common factor. And I'm actually going to divide out a y, because that's going to be part of my greatest common factor. So if I divide all those out, I get x squared minus 4y squared. and then I put my greatest common factor out here. Now I can check this to see if it's a special kind. So again, square root, this is like 1. So if I square root that, a becomes 1, and if I square root this, b becomes 2. Because I know the middle disappeared, just like this form here, and these are both perfect, I can just go 3xy, x minus 2y, and then x plus 2y. You can also switch these. It doesn't matter. The minus doesn't have to come first, but it does. As long as these match and one's minus and one's plus, it's this perfect or this special case. Okay? So that's my final factored form. Do not forget to put your greatest common factor that you divided out in front. Okay? That is something that people are making mistakes on, is they pull this out and forget that it's a part of our problem. It is still a part of my problem. Okay, why don't you pause and see if you can do this one? Okay, so let's start by doing that. So pause, see if you can try to do this one. So we square root this, I get a is 2. If I square root this, I get b is 9. So I get 2x, I can write plus 9 and 2x minus 9. Like I said, these can be flip-flopped as long as the front and the back are the same, and it's plus and minus. All right, on this one, I am actually going to pull out a 2 first. Okay, so I'm going to start this one for you. You're going to pull out a 2. You're going to get 25x squared minus, I believe that's 16y squared. So I'm going to start this one. I want you to finish it. What would my final answer be? All right, so it says, what is the radius of a cylinder that has a height of 3 inches and a volume of this? So this is kind of applying why we do these things, which I know seems really crazy, but we're going to factor this. See how there's a pi on the outside? We're going to leave that. We're going to first factor this. So let's use our section first, right? So let's not even worry that it says cylinder and radius and all this crazy stuff. Let's just worry about what our actual concept is. So we're going to take pi and then parentheses 27x squared plus 18x plus 3, and we're going to factor this, okay? So the first thing I'm going to do is I'm going to notice that there is a 3 that I can divide all these by, okay? And so I'm going to get 3 pi, because I just pulled that 3 out here, right? Parentheses 9x squared plus 6x plus 1, close the parentheses. So, since we're using special cases, if I square root this, a becomes 3. And technically, if I square root this, b becomes 1. If I take 3 times 1 times 2, I check and see that I actually did get 6. So that means this is a special case. And so I'm going to go 3 pi, because that's still on the outside. I'm going to go 3x plus 1 squared, because remember, this is that version where it's positive and it means it's a perfect square. So I go 3 pi parentheses 3x plus 1 squared. Okay, what we're looking for is very specifically the radius, and I know that seems weird because it's like, how can we find the radius if I don't even know the formula for volume of cylinders? So volume of cylinders is pi r squared times the height. So if I fill in what I know, pi will always be pi. I don't know the radius. I'm trying to find that. And I know the height is 3. I can move some stuff around and change it so that it says 3 pi times the radius squared. And then if we compare it to what we just did over here, look, there's my 3 pi. And here is my part that is squared. So that means that the stuff inside the parentheses is the radius. The radius is 3x plus 1 inches. So that's how you kind of apply this information. Okay, so I ignored all of this until I got all the way done, and then I compared it to this. And I know this is something that you haven't done, but so that's why I just gave it to you. But all I did was I used the commutative property of multiplication to move this here. I can multiply in any order I want to. And then I compared it. So there's 3 pi. I have that. So that means what I am missing is r squared. And if you notice what I have squared must then be the radius, because that's the only piece I'm missing. And so our radius would be 3x plus 1 inches. No, we don't know what that is. That's all it is. All right, so just the main things to remember are our special forms. Oops, let me do that. So there's that one. Yes, I just copy pasted. And then we have this one. I mean, these are all technically, oh, hold on, let me fix this. What was written before, so if you don't want to copy this down, you don't have to, technically, but all I'm doing is copying it from earlier. But these are those very special forms and definitely should be memorized. And then that last one is where one's minus and one's plus, right? It doesn't matter which one. And that's where this middle section is going to disappear. All right, there we go. Those are our 3 very special forms. These 2 are what we would call perfect squares, and then this one is not. All right, so here are your independent practice problems. So you're going to finish, you're going to do these 2, obviously, and then you need to go make sure this one got finished. All right, you need to go factor this and write down your final answer, okay? So you technically have 3 problems that I will be checking to make sure they're done. All right, adios, until next time.